Let's start our second slide for the case of for this course of particle physics. In this we will discuss about the fundamental forces. What are the fundamental forces? As I already told you, there are basically four fundamental forces. The first one is the gravitational force. As the name stands, gravitational. So it's basically from the gravitation. Yes, you are right. So it's basically gravitational force. uh, it's basically the weakest for the four forces. It's basically the weakest for from all the four forces. The first force, as you know, is the gravitational force. The second force is basically the strong nuclear force. The third one is the electromagnetic force, and the fourth one is the weak nuclear force. And all of above, the weakest force is basically the gravitational force. Okay, because why it is so much weaker? Because it acts like long distance. Okay, it has a long range. Gravitational force has a long range. Due to long range, this force is weaker. Governs the motion of planets, stars, and galaxies. You already know that the motion of stars, planets, and galaxies, this is all the motion by the concern for the gravitational force. Negligible at particle level. At particle level mean at fundamental level. At small, at micro scale level, this force is negligible. Because whenever we are dealing with a macro scale, means a huge distance, light year distance, many kilometers distance, then we concern the gravitational force. If you are in small scale, micro scale, like particle scale, elementary scale, then we will ignore this gravitational force. So let's move over towards second fundamental force, and our second fundamental force is the strong nuclear force. As the name as stands for strong, so yes, this is very strong force. So it's basically the strongest force, from all these four forces. Strongest force. Due to the strongest force, now its range is very short. So it acts only for short distances. Like strong nuclear force is basically inside the nucleus between proton and nucleus. In this side, the nucleus between proton and neutron. Because you know that its proton and neutron is basically a very micro scale. This strong force is whenever we concerned with the micro scale, very short micro scale, like 10 is per minus 10. Also small, like nucleus level up to 10 is per minus 15 femtometer. We use strong nuclear force, and this is the strongest force, and this is for short distances. Binds quark. As I told you, this is the only force that binds your nucleus, or you can say that binds quark, because you know that inside proton there are furthermore three quarks. Two up and one down. While in neutrino is the two down, one up. So it binds quark together in proton and neutron, critical for understanding jet production in particle collision. So strong nuclear force is basically critical, for understanding the jet production in the particle collision. Why it is critical? Because you know that we have to study the small scale, like micro scale means very much micro scale, like femtometers. Proton and neutron is in the range of femtometers, short distance. So we must have to discuss the strong nuclear force, and this strong nuclear force help us for the better understanding of jet production in particle physics. Now let's move on towards our next third fundamental force, and that force is basically the electromagnetic force. As the name stands for, electro means electricity and magnetic mean magnetism. The force due to electric field and magnetic field is so known as electromagnetism. Acts between charged particle. Why charge? Because electromagnetic field only generate whenever there are charges. So these are only acts between charged particles. If your particles are neutral, then there is no electromagnetic force. And this electromagnetic force is basically responsible for the phenomena like electricity, magnetism, and light. Because you know that whenever there are charges, there must be some electricity, and when there is electricity, there must be some magnetism property. And due to electromagnetic field, there must be some light. Infinite range, shorter than gravity. As you know that gravitational force is a very long distance, has an infinite range. It don't mean it is infinite, but it has a long range. But electromagnetic force have infinite range, stronger than gravity. This force is also stronger than gravitational force. It has infinite range. Which force? Electromagnetic force. But gravitational force is not infinite in range. It is long range, but this is not infinite range. Whereas your electromagnetic force is in infinite range and stronger than gravity. Okay. Now let's move towards our last force, and that force is basically the weak nuclear force. Okay, as the name stands for weak, so yes, this is a weak force. This force is basically responsible for the radioactive decay and neutrinos. Okay, like your proton decays into neutron. Okay, with an emission of electron. Okay, means beta decay, beta minus, with a emission of antineutrino. Okay, so weak nuclear force is only where when there is an emission of neutrino, and you can say anti-neutrino. So these are basically whenever this is included when there is radioactive decays. Okay. Now, what's the next point is basically it acts at subatomic scale, means small scale. Okay, relevant to particle interactions in high energy physics. So these are your four forces, fundamental forces. Okay. This weak force is also, you can say, between in the subatomic scale, and also between the interaction between the high energy particles, mean fundamental particles. So this is all about the fundamental forces we all discussed in this topic. Okay, so that's all for today. Thanks for watching. Stay tuned with us. We will upload more slides for this course. Allah Hafiz.